Welcome to Easy Limu Learning Simplified. My name is Eric. I'll be taking you through this lesson on volume and capacity. And for this particular lesson, we cover volume of a prism. So we want to see what a prism is and how we can find the volume of a prism. So how do you go about it? So we have a few questions here to help us with illustrations on how you can find the volume of a prism. And we have some assignments at the end of the lesson just to help you practice and also to help you check on your understanding of the concept as discussed during this lesson. So the volume of a prism is gotten by having the product of the area of the cross section and the length of the prism. So what defines a prism is when it has a uniform cross section. It has some cross section that has got some constant width. Maybe you could be having, you see. So this is uniform cross section, that is triangular and that is uniform all through to the end. So this is what we call the length, and then this is what we call the cross sectional area. So the name of the prism will depend on the shape of the cross section. It could be triangular, it could be square, it could be rectangular. So that will determine the name that is used for such a prism. So the product of the area of the cross section, like in this case, the cross section is triangular. So the area of this cross section here, you multiply by the length of the prism, will give you the volume of the prism. So volume, cross sectional area times the length, where CA is the area of the cross section and L is the length of the prism. So this formula is what you're going to use when it comes to finding the volume of a prism. Now you have to come to a point where you are concluding that it is a prism. For you to do that, you should be able to identify something like a uniform cross section, some cross section that does not change. So an example is calculate the volume of a prism whose length is 25 centimeters and the cross section is an equilateral triangle. So you'll have to find so if you have an equilateral triangle, maybe let me try and subdivide this. So you have an equilateral triangle. So equilateral triangle side 3. You can use, so the formula is that volume is going to be given by cross-sectional area times the length of the prism. So the length of the prism already we know is 25, but now we need to find the cross-sectional area. So I'm going to use the formula square root of S into S minus A, S minus B, and S minus C. So S, is half of the perimeter, which is half of what? Half of 9. So that is 4.5. Perimeter is 3 plus 3 plus 3, which is 9. So then it means then that area is going to be the square root of 4.5 into 4.5 minus 3. 4.5 minus 3 again. So 4.5 minus 3. So that is going to be the square root of 4.5. So this is supposed to be 4.5 here, multiplied by 1.5, multiplied by 1.5, and multiplied by 1.5. So that is going to be the square root of, if you do long multiplication of decimals and you multiply 4.5 by 4.5 by 4.5, no, by 1.5 times 1.5 times 1.5, that is 15.1875. 15.1875. That is if you use long multiplication. Remember we talked about multiplication of decimal numbers. So again, if you use the tables of square roots to help you find the square root of 15.1875, then you'll get 3.8971. So you can use the tables of square roots to help you find the square root of 15.19. So that you need to check that from the tables of square roots of numbers between 10 and 100. So already we have the area. So we need to find the volume, which is cross-sectional area times the length. So that is 3.8971 times 25. So again, if you use long multiplication method, see? So long multiplication method, if you multiply 3.8971, you'll get 97.43. 97.43 cubic centimeter. That is if you use long multiplication method to multiply 3. So we still have this. So we only have the cross section, which is trapezoidal. So it's a trapezium. So you need to find the area of a trapezium. So the formula still remains. So the formula still remains. Volume is given by cross-sectional area times the length. So length is 8. So what I need to find is the cross-sectional area, which is given here. But the challenge is that now I don't have the height. So how do I find this height? So you'll have to do this. So this one here is 2 centimeters. So that means this is going to be what? So this one here will be 1.5, 1.5. Because if you subtract 2 from 5, you get 3. That 3 is shared between these two lengths. So you divide the 3 you divide it by 2, you get 1.5, 1.5. And so from there, you should be able to find the height. Because this is a right angle triangle. So you can use Pythagoras theorem. So you have h is going to be the square root of hypotenuse squared minus the base squared. So again, if you use long multiplication method, you'll get 9 minus 2.25, which will be the square root of what? That is 9 minus 6.75. So the square root of 6.75. So again, if you use tables of square roots to find that, you'll get 2.598, 2.5981 centimeters. And therefore, the cross-sectional area will be a half, because this is trapezoidal, a plus b times height. So this will be a half times a plus b will be 5 plus 2, and height will be 2.5981. So that will be a half times 7 times 2.5181. So we have the cross-sectional area as 3.5. So 7 here divided by 2 is 3.5 times 2.5181. So again, you need to use long multiplication method. We have talked about a multiplication of decimals to multiply 3.5 times 2.5181, and that will be 8.8134 square centimeters. So volume should be cross-sectional area, which you have calculated, times the length. So cross-sectional area is 8.8134. You multiply by the length, which is 8. Again, if you use long multiplication method, you should be able to get this as 70.51. So that is how you go about it. It's doable. It is something that is manageable. So we have a few questions here to help us practice on what we have learned. You can always attempt. When done, you can always be posting feedback on the comment section. We'll be able to look at it and give feedback. Otherwise, that is all for now. Until next time.